On the Mach 1 machine, after you've done your design and placed it on the material, the last step before cutting it out is to give it the right parameters so you get a perfect cut. To do that, you're going to want to click on the Materials pane, which is the third button on the left on the bottom pane. Once you click on that, you're just going to give it a little bit of information about the material you're using, the torch tip you're cutting with, as well as what material you're using, and it's going to pull up the right parameters for that material, for that combination. So in this case, let's go ahead and say that we are cutting with acetylene and it's a Kawiki style torch. If you're using the old style CN-Seamless torch, which was a Harris, you're going to want to select the correct torch and fuel combination for that torch. Propane Kawiki. Once you've selected that, you've got a couple different options. You can either start with the material and thickness you're cutting and see what torch tip it recommends, or you can say what torch tip you're cutting and then go back and select your material. In this case, let's go and say we're cutting whatever this table is made of. So that's steel, and it is 1-inch thick steel. You can see here now that the torch tip it recommends is a number 2. Once you select the combination of things you're using, it's going to pull up the cut settings here on the right. I'll go into more detail about what each one of these settings means in a little bit. Underneath your torch tip and fuel selection, you also have a couple other options for the cut. The preheat timer is going to be useful if you're cutting multiple shapes out at once and you don't want to have to sit there and click pierce manually for each one. So if you turn the preheat timer on, once it goes to a new cut, it's going to wait for a certain amount of time and then pierce automatically. The amount of time it's going to wait is going to be that preheat timeline right there, right here. The move machine to top before cut setting is useful if you're cutting really low down. So say you're cutting deep in a channel, you have your torch low and the machine is already low. You can turn this off, and instead of moving to the top, going to the cut, going back down, it'll just stay at that height during the rapid. If you have this turned off, just make sure there's nothing in the way of the torch. So if it moves, it doesn't hit anything. So pretty much everything else we've shown on the machine has been kind of agnostic to which attachment you're using, whether it's the torch or the plasma. But I'm going to go and plug in the plasma module and show you a couple differences between the two. So flip this up, slide this out, and plug in our plasma module. So you can see now it's changed to plasma mode and it's gone ahead and cleared out all of the selected things we had already done because it's a new attachment. So you'll see here there's a couple new options. So first one, instead of the torch style you're using, it's going to be whatever plasma cutter you're using. So we use the Hypertherm 85 a lot. The next step is our probe method. So what this is doing is telling the machine whether you're going to either lower it by hand with the buttons on the side here, or you want to have it probe. And then if you're going to have it probe, you're going to want to have your probing cable here, which comes in the box. This is going to screw right on the top here. And then when it goes to a new cut, it's going to lower down until it touches off, and then it's going to know the right height to cut at. Before you do that, you're going to want to go ahead and run this probe test here, this test button, to make sure that you have a completed circuit. The way the probe works is that it detects whenever this piece of metal or your torch tip itself touches the material, it's going to close the circuit through your material, through the magnet on the machine, and back out to the plasma module. So if your material has a very thick layer of mill scale, or rust, or paint, anything else like that, you might not get a complete circuit and the probing won't work. So let's go ahead and click on test here, and then we're going to touch this metal piece on the probing cable to the material, and you're going to want to make sure that you get that little flash of green there. This is a pretty mill scale covered material, so it's not staying green, but the fact that it's turning green at all is a good indication that it is working. So we can go and stop that test now. The next setting, the move machine to top before cut, same as Oxyfuel. Torch height control is you're enabling the voltage-based feedback on the machine so that it can keep the height correct if you're cutting on really warped material or it's like a pipe or something like that. And then this plasma cutter voltage divider is related to torch height control. So there's the raw voltage off the torch arc, but the plasma cutter will typically have an internal divider in that. So if the voltage on the arc is 100 volts and your divider is 50-1, the actual voltage the plasma module is going to read is going to be 2, and so you would set that to 50-1. You can find this value in the manual for your plasma cutter. The other setting that is plasma specific is going to be this override loss plasma arc detection. So one of the signals the plasma module gets from the plasma cutter is whether the arc is good. So when you first strike the arc and it's just that pilot arc on the plasma cutter, it's going to not be confirmed by the plasma cutter. But once it transfers that arc to the material and you're actually cutting, the machine will know that it's actually completed that arc and it's making a good cut. Now, this is also sensitive to dirty material, mill scale, rust, things like that. So unless you're cutting on really clean material, I would go and leave this override on. If you have the override off, whenever it detects that it's lost the arc, the machine's going to automatically pause itself, and it can be kind of a pain to have to, re-pierce every time it senses that. So I would typically leave that on unless you have really clean new material. Even like hot roll can sometimes be enough mill scale to make that signal oscillate. So once you've actually selected what you're going to be cutting with and selected all your settings, you're going to see the actual cut settings that's going to pull up here on the right. I'm going to go through what each one of these means so you know what is going on when you're using the machine. First one is the most self-explanatory. That's the feed rate. So that's how fast this is moving during the cut. So thicker material, lower amperage is going to be slower, thinner, higher amperage, faster. The lead-in distance. So if I go over here to run and zoom in, you're going to see there's a lead-in right there, just like this. If I were to go edit this and change this to say a 0.6 inch lead-in, that lead-in gets bigger. So if you are piercing and you're noticing you're getting a lot of slag and it's messing up your cut because it's really thick or it's cold out, so it takes more slag to pierce through, you can go here and increase that lead-in distance to a better value. The next setting you're going to see here is the pierce delay. So on the plasma, that is when it turns the signal on to the machine to turn that arc on, how long it's going to wait there before it starts to move. On really thick plate especially, it takes some time for it to actually make its way all the way through the material and get a good cut. So it's going to sit there, in this case, for half a second before it moves. If you don't wait long enough and it starts to move, you end up with like a rooster tail because it hasn't cut all the way through. So that's one thing to watch out for. It's the same thing on the torch. It turns that oxygen jet on, how long it waits before starting to move. The next thing is going to be your pierce height. So that's how high above the cut height it's going to raise when it does the pierce. You want to raise up when you do the pierce so you don't blow slag into your consumable or your torch tip, which lowers the life of those consumables. You can adjust that as well. The next one is going to be your kerf width. You really shouldn't have to mess with this one, but that is how thick the cut line is itself. So just like when you're cutting a 2x4 with a circular saw, you offset it to one side of the line or the other. It's the same thing with the kerf width. And that's directly proportional to however big the cutting jet hole is on your torch tip or the consumable orifice size on the plasma. The voltage, so this is only really going to take effect when you have torch height control enabled. So what that is the machine is going to try to keep a constant voltage on the arc. So the plasma cutter itself is going to do the job of keeping the amperage to whatever you set on the screen, but the voltage of that arc is based on how long the arc is. If you're really close to the material, it's going to be a low voltage. If you're really high, it's going to be a high voltage. So if you have torch height control enabled, you can kind of indirectly control the height by adjusting that voltage. And then finally, we have the cut height. So when you have probe enabled, when it touches off the material, it's going to raise that much above where it detected the material is to cut. So a lot of these are going to be kind of hard for me to show you with the machine here, but hopefully that's a good explanation of what those are. The last one I want to show you is not one that's on the plasma, but it's on the Oxyfuel. So if I plug this back in, you'll see that some of the values have changed. So what you can see now is that there is a preheat time setting as well. So when you're cutting with the torch, it takes some time for it to preheat the material before you can turn that cutting jet on and actually start to cut. But the preheat time setting is going to be how long it waits at the pierce point before turning the cutting jet on. So if you have like say a circle pattern with multiple circles, that first circle on the run screen, you're always gonna have to click pierce because it doesn't know when you've actually lit the preheat flame, gotten to the right height, and are good with all of that. But on those subsequent circles, it's going to finish the last one, move to the next cut, sit there for however long the preheat time is, turn that cutting jet on, then wait for the pierce delay, and then finally start moving. So I'm gonna do a cut real quick and show you kind of how all these things can interrelate to each other.